Hello, in today's video we're going to be continuing and finishing section 6.2 on right triangle trigonometry. In our first video we discussed sine, cosine, and tangent and how those values gave us the ratio of two sides in a right triangle depending on the size of the angle that we're looking at. So if I'm looking at t, which is one of the acute angles in this right triangle, sine would then be the opposite side over the hypotenuse. So this t, if it grows, then the relationship between hypotenuse and opposite side is going to change, and if it becomes smaller, then that relationship between opposite and hypotenuse side will change accordingly. Similarly, we have cosine of t, which relates the adjacent side to the hypotenuse, and tangent is opposite over adjacent. The hypotenuse is always across from your 90-degree angle, and your opposite and adjacent sides are always legs of your right triangle. Legs are the sides that are attached to that 90-degree angle. So the opposite and adjacent side are always attached to the 90-degree angle, and your hypotenuse is always across from your 90-degree angle. To solve right triangles, what we are going to do is we are going to find all unknown values. And this means we are going to find the values of the lengths of the sides as well as the angles. So I can find this first unknown value, this angle here, by simply saying that all three angles must add up to 180 degrees. So if I have 180 being the entire triangle and I subtract 90 for that right angle and 28 for the other acute angle, then I'm going to find that that missing degree is going to be 62. So this angle is going to be 62 degrees. Now from here, I need to find two sides. I'm missing the hypotenuse and I'm missing one of the legs. So I'm going to use trig to help me do this. If I look at my 28 degrees, the 12 is the leg opposite my 28 degrees. If I am trying to find the other leg, this leg on the bottom, this will be the leg that's adjacent to my 28 degrees. So I have the opposite leg and the adjacent leg that I am looking at. Well, if we go back a slide, if we don't quite remember yet, the opposite and adjacent ratio is found by using your tangent function. So that tells me that the tangent of the angle I started at, which is 28, will give me that relationship between the opposite side, 12, and my adjacent side, which is unknown. So tangent of 28 is going to equal 12 over, and I'll go ahead and use A for adjacent. So what I'm going to do now is simply plug in tangent of 28 to my calculator. This value is constant, so my calculator is going to give me that exact ratio for the tangent of 28. On this calculator, we need to type in our angle measure first. So I have 28, and then I'm going to tell the calculator that I want to take the tangent of that 28, so I'll hit tangent, and it will tell me the exact ratio for that value. So my tangent of 28 is approximately 0.532 if I round. So my tangent of 28 is approximately 0.532, and that's equal to 12 over my adjacent side. Now I can go ahead and solve for my adjacent side. I'll multiply by A first to get 0.532A is equal to 12, and then I will divide by that 0.532 to isolate A. Pulling my calculator back up, I need 12 divided by 0.532. And I find that A is approximately 22.56. So this adjacent side is approximately 22.56 units. We can use a similar strategy to find the length of our hypotenuse. So I'm going to start with the 28 degrees, and I'm going to use the opposite side. And I'm using the opposite side because that was given to me already. I can use the adjacent side, but it's safer for me to use the opposite. If I'm trying to find the hypotenuse, then I want the trig function that relates the opposite with the hypotenuse. So going back, I've got my sine function using the relationship between the opposite and the hypotenuse sides. So I'm going to use the sine of 28 degrees to determine the ratio between the opposite and the hypotenuse sides. So sine of 28 is going to be equal to the opposite side, which is 12, over the hypotenuse, which I'll go ahead and call h. I pull up my calculator and evaluate the sine of 28. So I hit 28, then I hit sine, and I find that that value is approximately 0.47. So 0.47 is equal to 12 over h. And then when I solve for h, I've got 12 divided by 0.47, giving me a hypotenuse that is approximately, let me pull that back up, 25.53. So this hypotenuse is approximately 25.53. So we have solved the right triangle because we have found all of the 6 values. We've got 3 angles and we have 3 sides. So we are done. Go ahead and take a moment, pause the video, and try out these few on your own. I'll go ahead and start us off here. If I want to find the adjacent leg, I have the opposite side of 52 degrees, and I want that adjacent. So I'll go ahead and use the tangent function of 52 degrees, which is equal to the opposite side in the triangle over the adjacent side. And solving, A is going to equal approximately 9.38. To find the hypotenuse, I have the opposite side in the hypotenuse, so that would be sine of that 52 degrees is equal to the opposite leg, which is 12, over the hypotenuse h. And solving, h is going to equal approximately 15.23. So the only other thing that we are missing, we've got all 3 of our sides. The only other thing that we are missing is our third angle. So to find that third angle, I know that all 3 add up to 180. I take away my 90 and I take away my 52 to find that that third angle is going to be 38 degrees. So our triangle has been solved. Our solutions for the remaining 3 triangles are going to be the values that I have shown in each of these triangles. We're going to move on into talking about 2 new concepts, and that would be angles of depression and angles of elevation. An angle of depression is the angle between the line of sight and a horizontal if an object is below a horizontal. So for example, you might have an airplane that is flying with an angle of depression of about 60 degrees down to a point on the ground. So that means that from this horizontal, my angle would go down towards the ground at 60 degrees, and this would create the angle of line of sight to whatever that object is on the ground. So we went from a horizontal down to a point somewhere below. Angle of elevation would then be something like from the ground, we are looking up to a point on a building, and this would be an angle of elevation because we are looking up. So it is from the horizontal to whatever your line of sight is. If it's going down, then it's an angle of depression. If you are looking up, it would be an angle of elevation. So here we have a giant redwood tree. So I'm going to draw my tree, casting a shadow that is 532 feet long. And we are asked to find the height of the tree if the angle of elevation to the sun is 25.7 degrees. So that means from the end of my shadow, we are going to elevate up to the sun. So the shadow is going to be my horizontal. We hit the top of the tree because that's what creates the shadow, and then the sun would be somewhere up here. So here is my triangle. Assuming that the tree grows straight up, this will be a 90-degree angle, and we are asked to find h when this angle is 25.7 degrees. So I have the adjacent leg, and I want to find the opposite side. So I have adjacent and opposite. The trig function that uses adjacent and opposite is tangent. So the relationship is that tangent of my angle 25.7 is equal to the opposite side over the adjacent side. So tangent of 25.7 is equal to h over 532. Plugging that into my calculator, I can multiply both sides by that 532. So 532 multiplied by the tangent of 25.7. So 25.7 tangent of 25.7 multiplied by that 532 is 256. So we have found that h is approximately 256. So our tree is approximately 256 feet tall. Go ahead and pause the video and try out that next one on your own. Here we have a lighthouse that is 200 feet tall. The angle of depression, so here is my horizontal, and we are going down to a ship in the ocean at 23 degrees. Here's my boat. We want to know how far the ship is from the base of the lighthouse, so assuming the lighthouse is at a 90-degree angle. This angle here is also 90 degrees, so if my angle of depression is 23 degrees, the rest of that 90 would have to be 67 degrees. And what we are trying to find here is d, distance. That distance is the opposite side from my 67, and I have the height, which is the adjacent side. So again, I'm going to say that the tangent of that 67 degrees is equal to the opposite side, which is d, over the adjacent, which is 200. Multiplying both sides by that 200 to solve for d, I punch this into my calculator. So I've got 200 multiplied by and then 67 tangent of 67 to get a total of 471. So the distance is approximately 471 feet. From a point on a ground 500 feet from a base of a building, an observer finds that an angle of elevation to the top of the building is 24 degrees, and that an angle of elevation to the top of a flagpole atop the building, so we're going to have a second angle here, this angle is 27. Find the height of the building and the length of the flagpole. So we are just going to create two triangles. The first thing I'm going to do is find h of the smaller triangle, and then I'm going to find the height of that larger triangle. So I'll call this h sub 2. So my first smaller triangle, I have the opposite side and the adjacent. So again, the tangent of that 24 degrees for my smaller triangle is equal to the opposite side divided by the adjacent side, and I multiply both sides by 500. On my calculator, 500 times the tangent of 24 gives me a value of 222.6. So this height is approximately 222.6. That is the height of the building. The height from the bottom to the top of the flagpole, tangent of the larger triangle, 27 degrees, is still the opposite, h2, over that adjacent side, which is 500. And again, I multiply both sides by 500 and plug that into my calculator. 500 times the tangent of 27 is going to be 254. So the height of the building is 222 feet, and the height of the flagpole from the bottom all the way to the top is 254, which means that the height of the flagpole itself is just the difference of those two. So 254 minus 222.6 gives me a flagpole that's approximately 32 feet. So the flagpole is approximately 32 feet. All right, we've got one more and then we are done for the day. So go ahead and pause the video and try this one out on your own. Starting this off, we should draw a picture that should look something like this. I've got an airplane with an angle of depression of 35 and 52 degrees down to each of our two motorists. Because this whole angle here is 90 degrees, I can fill in the two angles of those triangles. Each of these triangles is also a right triangle, and I am trying to find the distance between my cars. So I'll call this distance 1 and this distance 2. Given the angle, I have the adjacent side. I want the opposite side, so I will use tangent. I find my first distance is 7,354, and my second distance I will also use tangent, and I get 4,023. So the total distance between these two cars then is 11,377 miles. And that brings us to the end for today. Thanks for watching.